Now, we will proceed with the fatty acid synthesis. Fatty acid synthesis occurs in the cell cytoplasm. Signals for the fatty acid synthesis could be regulated by two types of regulators, which is the allosteric or the hormonal regulator. For the allosteric activator, it is citrate, which in the first step of fatty acid synthesis, and the inhibitor is the long-chain fatty acids itself. For the hormonal regulator, the activator is insulin and the inhibitor is glucagon. These two can be seen especially during our fit or fast state, and this regulator affect our activity rate of acetyl-CoA carboxylase enzyme. Stage 1 of fatty acid synthesis, transport of acetyl-CoA to cytoplasm. Fatty acid synthesis starts with 2-acetyl-CoA that is usually derived from glycolytic pathway of glucose in mitochondria, brought to cytoplasm by forming citrate with oxalic acetate when there is a build-up of acetyl-CoA in mitochondria. In the mitochondrion, acetyl-CoA will bind with oxalic acetate to form citrate and be transported out to the cytoplasm. This citrate will be the signal for the fatty acid synthesis. In the cytoplasm, the citrate will break down to acetyl-CoA and oxalic acetate again. Only acetyl-CoA will be used in the fatty acid synthesis, while oxalic acetate will transform to pyruvate and be transported back into the mitochondrion. But in the process, they will produce NADPH, which later will be used as the reducing agent in fatty acid synthesis. Stage 2 is the carboxylation of acetyl-CoA. 1-acetyl-CoA is converted to malonyl-CoA by enzyme acetyl-CoA carboxylase by adding a carboxyl group to the acetyl-CoA. And the last stage, stage 3, the assembly of fatty acid chain or the adenylation phase. There will be 5 steps in this stage. Step 1 is the loading of precursor via thioester derivative. 1-acetyl-CoA and 1-malonyl-CoA have their CoA portion replaced by a carrier protein known as ACP to form acetyl-ACP and malonyl-ACP. Step 2 is the condensation reaction, where acetyl-ACP bind with malonyl-ACP to form acetoacetyl-ACP by the enzyme acyl-malonyl-ACP condensing enzyme. Step 3 is the reduction reaction, where acetoacetyl-ACP is reduced to D3-hydroxybutyryl-ACP by the enzyme beta-ketoacyl-ACP reductase with NADPH as the reducing agent.